Welcome to Solera's Nature Positive Production, Episode 3 of our Deep Dive series. Today, we're embarking on an absolutely incredible journey. We're tracing this epic story of African cattle and looking at how their centuries of evolution are, well, really shaping the future of sustainable agriculture right now.
Indeed. It's quite a story. We're going to unpack, about 700 years of cattle evolution, exploring how ancient wisdom, this profound resilience they developed, and cutting-edge modern science have all come together. Our focus today is really how this incredible history feeds directly into what we call nature-positive production for today's cattle producers and, importantly, for consumers, too, especially through the innovative Solera framework.
And the source material you've shared, it's remarkable, a genuine saga, really, of resilience and genetic marvel. So our mission today is to pull out the most important nuggets of knowledge from this epic journey source. We want to show you how this historical story isn't just, interesting history, but how it directly underpins and contributes to the innovative Solera framework we're talking about.
Exactly. Think of it as understanding the deep roots, the really deep roots of what is actually a revolutionary approach to sustainable agriculture. What's truly fascinating here, I think, is how solutions to some of our biggest challenges today, things like climate change, biodiversity loss, the need for truly sustainable food systems, these solutions aren't always brand new inventions. Sometimes they're found in legacies that are literally hundreds of years old. It sort of challenges us, doesn't it, to redefine what innovation really means sometimes.
Okay, let's unpack this journey then. Starting way back in the year 1300, can you paint a picture? Imagine the vast, vibrant savannas of southern and eastern Africa, near Great Zimbabwe specifically. Something pretty remarkable was happening there with the Shona people and their cattle.
Oh, absolutely remarkable. This period, it reveals sophisticated cattle breeding programs. Sophisticated on a scale and with a foresight that frankly impresses even modern geneticists. The Shona developed practices that, well, maybe they weren't writing scientific papers, but what they did is clearly recognizable today as highly effective selective breeding protocols.
Okay, like what kind of evidence do we see?
Well, the archaeological evidence from Great Zimbabwe is quite telling. We see these detailed cattle enclosures, kraals they're called, designed with real precision. Not just simple fences, you understand. These were structures that allowed for size-graded enclosures, different age groups separated, breeding stock kept apart from others. They even had sophisticated water management systems, creating these sort of localized microenvironments, ensuring optimal grazing, optimal growth conditions, even when things got dry.
Yeah.
And what's particularly insightful, I think, is their ritual selection ceremonies. Beneath the spiritual significance, which was undoubtedly important, they employed very practical genetic selection criteria. They favored animals that survived best, that produced consistently, that just thrived in that specific environment.
So the cattle that came out of these programs, they weren't just, average livestock. They had traits that, looking back now, seem almost miraculous, didn't they?
Absolutely. Miraculous is a good word for it. These Sangha cattle, they're the direct ancestors of today's really valuable Tuli, Nguni, and Mashona breeds. They showcase truly incredible adaptation. Just incredible. For instance, their heat tolerance. It was extraordinary. They could keep grazing, keep thriving in midday heat over 40 degrees C. That's over 100 Fahrenheit. Most European breeds would just, shut down. Find shade, stop eating.
Right.
And they also show this remarkable inherent resistance to really devastating diseases, like trypanosomiasis.
Yeah.
That's a parasitic disease spread by tsetse flies. It often just wiped out entire herds of European cattle, sometimes in weeks.
Wow. And fertility, too.
Oh, absolutely. Their fertility rates consistently topped 90%, even in tough, nutrient-poor environments. And their feed efficiency was remarkable, converting sparse savanna grasses into high-quality protein. Really, really effectively.
And modern science has actually figured out why, right? Not just seeing it, but understanding the genetics behind it.
Precisely. Modern genetic analysis, using today's sequencing tech, has revealed what we call the Sangha advantage. It comes from unique combinations of specific genetic traits. Things like particular heat shock protein variants. Think of them like tiny shields inside the cells, protecting them from heat damage and stress. They also have specific trypanotolerance genes inherited from way back, from ancestral Hamitic longhorn cattle. That gives them natural immunity to that parasite.
Incredible.
Add to that their efficient water metabolism. They can thrive on minimal water, and these enhanced immune system markers giving broad disease resistance. It's really a complete package for resilience.
So the clear takeaway here, it seems, is that this ancient wisdom, this deep understanding of adaptation based on genetics, it didn't just vanish. It laid the foundation, really, showing us exactly what kind of inherent resilience is key to developing robust, truly nature-positive production systems for today.
It's a powerful lesson, isn't it? Looking back to move forward.
Okay, now here's where it gets really interesting, I think. Fast forward a few centuries. We're in the age of exploration. European explorers like Vasco da Gama rounding the Cape of Good Hope back in 1497. Their ship's logs, they actually noted cattle of extraordinary vigor and beauty among the Khoikhoi peoples. And these were the ancestors of the Nguni cattle we know today.
Exactly. And then the arrival of Dutch settlers at the Cape in 1652. That marks a pivotal moment. It led to the first sort of systematic comparison, though often quite brutal, it has to be said, between European and African cattle genetics. And the results, well, they were pretty humbling for the European breeds.
How humbling.
Very. In their first-year trials, African cattle had survival rates around 95%. Stunning. European cattle, they struggled. Only about 23% survived that first year. And Nguni cattle consistently showed calving intervals of 365 days, basically a calf every year. European breeds were more like 450 days, sometimes longer. Yeah. And disease outbreaks, which were inevitable. Nguni had less than 5% mortality. European breeds, over 60%. Yeah. It wasn't just a small difference, it was profound. It directly challenged their assumptions about, agricultural superiority. This data wasn't just numbers, it felt like a mandate from nature itself.
That's an absolutely stark contrast, just shows that innate resilience. And these early encounters, they also led to the first documented cases of crossbreeding success in Africa, didn't they? Like an early kind of genetic engineering happening right there on the ground.
It's exactly right. Records from the Dutch East India Company archives, they show deliberate breeding experiments as early as 1680. Dutch farmers started crossing their Frisian cattle with the local Nguni stock. And the offspring, these became known as Afrikaner cattle. They immediately showed what we now call hybrid vigor. It was a clear demonstration right there of the benefits of combining these distinct genetic pools. They were more productive, yes, but crucially more resilient than either parent breed alone in that challenging African environment.
But it wasn't just the colonial powers observing this stuff. The Zulu kingdom, under famous leaders like King Shaka, they developed this really sophisticated pastoral military economy, where cattle breeding wasn't just farming, it was like a matter of national security, strategic power.
That's a crucial point, yes. Observers, like the British adventurer Henry Francis Fenn, they actually documented these remarkable Zulu breeding protocols. They weren't just raising cattle for food, no. They were breeding them for specific military and economic roles. This involved rigorous performance testing for young bulls. They had to show strength, sure, but also speed, endurance, even fighting ability. Traits that were critical for moving armies, for defense. The Zulu also maintained a kind of genetic record-keeping through really complex oral traditions, tracking bloodlines meticulously over generations.
Wow, oral records for genetics?
Yes, and for environmental stress testing. They put their herds through forced marches during military campaigns, pushing them to their limits to see which individuals were truly the most resilient. All of this really led to the perfection of the Nguni cattle. Animals so perfectly adapted they became essentially the gold standard for tropical beef production. They underpinned a powerful nation.
It's incredible to think of integrating cattle breeding right into national security like that. What specific challenges were they facing that made livestock so strategic? This raises an important question, doesn't it? How did these early encounters, these military strategies, start to highlight the undeniable superiority of African genetics? And how did that set the stage for the sustainable practices we see now, like in the Solera framework?
Well, it was multifaceted. Cattle were wealth, yes. Currency, food, absolutely. But they were also strategic assets for logistics and warfare, moving armies across huge distances. So maintaining large, healthy, mobile herds was absolutely vital for a powerful, expanding kingdom like the Zulu. This meant that resilience we keep talking about wasn't just a nice to have. It was essential for survival and dominance. The Zulu demonstrated very clearly that the right genetics weren't just about producing more milk or meat. They were about strategic advantage, national strength.
Okay, moving into the 19th century. This brought European scientific methodology into the mix with African cattle breeding, leading to this fascinating collision, you could say, of indigenous knowledge and Western research protocols.
Indeed, a real collision. You had Cecil Rhodes, the British South Africa company, driven mainly by economic interests, launching the first really systematic study of African cattle genetics. Their company vet, Dr. Arnold Thieler, documented performance comparisons that, well, they influenced breeding decisions for the next 100 years. His comparative study from 1895 to 1900 was huge, over 10,000 head of cattle, 5 different breeds. And the data he collected was just stark. irrefutable. Mortality rates over 5 years. Shona, just 3.2%. Thule, even better, 2.8%. Compare that to imported Herefords at 24.7%. And imported Shorthorns, even worse, 31.2%.
Right.
It is. And Dr. Thyler's reports included a truly prophetic observation. He wrote, "The native cattle possess adaptations that cannot be replicated through management alone." He continued, "Their genetic constitution appears specifically designed for African conditions." He got it. He understood you couldn't just feed a European cow more and expect it to perform like a sangha in that environment.
And then, almost unbelievably, there was this huge unintentional field trial, the Great Trek Genetic Experiment.
Yes, the Voortrekker migration from 1835 to 1845. This massive movement of people inadvertently became the largest uncontrolled cattle experiment in history. As thousands of people moved across vast distances through harsh disease zones, through severe droughts, the journal entries of leaders like Pete Retief give us definitive proof of genetic superiority. European cattle, catastrophic losses, 70 to 80% mortality during the journey. The Afrikaner crossbreds, showing that hybrid vigor we mentioned. Better, but still high losses, maybe 15, 20%. But the pure African cattle, their losses were less than 5%.
Less than 5% versus 80%.
Exactly. This mass migration, done out of necessity, proved beyond any doubt the absolute need for African genetics for survival, for resilience in those tough African conditions. It was a brutal, real-world validation of what the Shona and the Zulu had already mastered through centuries of careful breeding.
That's a powerful and, humbling lesson from history. So connecting these dots, what does this all mean for us today? It shows how even these large-scale, unplanned historical events gave undeniable proof of the genetic advantages we're discussing. Advantages that are now being consciously harnessed in nature-positive production through frameworks like Solera.
It means that nature, essentially, provided the blueprint for resilience. Human history then provided the undeniable evidence, sometimes tragically, sometimes through meticulous observation, that these cattle possess something truly unique, something essential. And this laid the intellectual groundwork for scientists eventually to stop trying to force, square pegs into round holes, and instead to embrace what nature had already optimized over millennia.
Okay, so the early 20th century. This marks a pivotal shift, right? Systematic scientific investigation starts to really understand, on a genetic level, what indigenous peoples had known for centuries through practice and observation.
Yes, this scientific deep dive was really spearheaded by institutions like the Onderstpoort Veterinary Institute, established 1908 in South Africa. It became a global leader in tropical animal health. Groundbreaking studies like Dr. P.J. Du Toit's seminal work on trypan intolerance in the 1920s and 30s, they didn't just observe resistance. They meticulously revealed the specific genetic markers for disease resistance in sangha breeds. They identified inherited immunity factors that were just completely absent in European breeds, and they even discovered the metabolic adaptations allowing these cattle to efficiently synthesize protein from low-quality forage. That was unheard of for many breeds. His 1925 paper, The Genetic Basis of Tropical Adaptation in African Cattle, it basically became the foundational text for modern crossbreeding theory worldwide.
And these weren't just lab studies, were they? There were big field programs putting the science into practice.
Absolutely. In what was then Southern Rhodesia, the Department of Agriculture launched one of the most comprehensive cattle breeding programs ever seen in Africa. Led by a geneticist, Dr. Harold Mason, from 1920 right up to 1945. This program was incredibly meticulous. They kept individual performance records for over 50,000 cattle. Tracked everything: birth weight, weaning weight, growth rate, carcass quality, everything. They pioneered progeny testing, identifying superior sires by looking at how well their offspring performed. And they even did environmental stress testing under controlled conditions to really understand the limits.
And the results.
Consistently astounding. Thule cattle, for instance, averaged 180 kilograms weaning weight versus only 165 kilograms for imported breeds in the same conditions. They had a 92% conception rate versus just 67% for the imported stock. Think about the economic impact of that alone, and an incredibly low 2.1% mortality rate compared to 18.3% for the imported breeds. Shona cattle. They reached market weight in 720 days compared to 890 for crossbreds, had a higher dressing percentage, 58% versus 52%, and could actively graze at a remarkable 42 degrees C, way beyond the 35 degrees C max, where European breeds just seek shade.
It's incredible. And you mentioned earlier the urgency of World War II even highlighted their strategic importance. African breeds kept producing vital protein during severe drought, while European breeds needed like 40% more feed for the same output. Shows their efficiency under stress.
Precisely. That wartime data really underscored their critical value. Then, moving into the post-colonial period, there was this sort of renaissance of research. focused on integrating all this knowledge. Dr. Ian Mapofu's work at Matipos Research Station in Zimbabwe from 1965 to 1980. He did a remarkable 15-year comparative study, 20 different cattle breeds, and his work validated traditional knowledge with really rigorous scientific data. His key findings, which later directly influenced the Solera system, showed that hybrid vigor really peaks in those first-generation F1 crosses between genetically distant breeds. But crucially, he also demonstrated that three-way crosses, combining African Sangha, European Bos taurus, and Asian Bos indicus genetics, showed optimal adaptation and sustained productivity over time. He also established that you could maintain heterosis, that long-term hybrid vigor, through rotational breeding systems. That was key. Plus, the formation of the Thule Breed Society in 1961 marked the start of systematically promoting these superior African genetics internationally.
This raises an important question then. How did this detailed scientific validation transform what maybe some people just considered native wisdom into globally recognized genetic excellence, paving the way for our understanding of nature-positive production today?
Well, it stripped away the assumptions, didn't it? It provided the undeniable, quantifiable proof. Proof that this wisdom was actually sophisticated, empirically derived knowledge built over centuries. It shifted the conversation from anecdote to hard data, from just local practice to clear global potential. And that really set the stage for these genetics to become a cornerstone of sustainable agriculture worldwide. Yeah. Because the science backed up every single claim about their superior adaptation and efficiency.
Which brings us to the convergence point. The moment centuries of selective breeding met cutting-edge reproductive technology. Dr. John Frisch's 1990 expedition to bring these genetics to Australia, this was truly pivotal.
It absolutely was. And the use of the Cocos Islands as a disease-free quarantine station for that expedition, unprecedented in its scientific rigor. It involved complete pathogen screening, painstaking genetic verification using DNA analysis to ensure breed purity. They had to be sure they had the real deal. Those 74 animals that finally arrived in Australia weren't just cattle. They carried incredible genetic diversity, a living legacy, really, representing centuries of natural and human selection pressure.
And the commercial validation followed pretty quickly.
It did. As Kidman & Co. trials, big pastoral company, ran from 2000 to 2010, showed remarkable results. A 20% improvement in weaning weights, a 15% reduction in mortality, a 25% jump in conception rates using Thule crosses. In NAPCO, another major producer, their data from 2005 to 2015 reported an average of $150 per head additional profit for Thule cross steers, mostly due to lower management costs and getting better prices for that consistent high-quality carcass.
And this is where the Solera system comes in, really completing the circle. It takes this amazing 700-year journey and culminates it, aligning it directly with nature-positive production for today's world. It's the practical application of all this deep history.
Precisely. The Solera system is a direct, intelligent response to today's big environmental pressures, climate change, biodiversity loss, the urgent need for true sustainability in how we produce food. This is why these African cattle genetics aren't just, relevant, they're more critical than ever. The Solera framework embodies nature-positive production in action. How? Well, their natural grazing patterns, honed over millennia, they actually enhance soil carbon storage. Being inherently heat-tolerant means less stress, less pressure on native ecosystems, no need for energy-guzzling cooling systems, their superior water metabolism. Significantly less environmental water demand compared to less adapted breeds. Their inherent disease resistance minimizes the need for pharmaceuticals, better for the environment, better for costs. And their improved feed efficiency directly means reduced greenhouse gas emissions per kilo of protein produced.
And the core of Solera is its three-way hybrid system. Can you unpack that genetic optimization? Why is that specific approach so effective?
Right, it's a very strategic integration of three key genetic tools. Each one brings vital strengths to the table. First, you have the Sangha genetics from Africa Thule, Shona bringing that foundational heat tolerance, disease resistance, high fertility we've discussed, the bedrock really. Second, you bring in Bos taurus from Europe. Breeds like Angus or Hereford, they contribute excellent growth rates, top-notch carcass quality, and importantly, broad market acceptance. And third, you add Bos indicus from Asia, like Brahmin influence. That adds specific tropical adaptation, especially for humidity, great maternal efficiency, and longevity. This comprehensive three-way approach ensures optimal adaptation across diverse environments. It maximizes productivity through that hybrid vigor, and crucially, it allows for maintained heterosis, keeping that hybrid vigor going strong generation after generation through careful rotational breeding. It's designed to be a truly robust and sustainable system for the long haul.
So bringing it all together, What does this all mean for you if you're a modern cattle producer listening or a conscious consumer? The benefits seem incredibly comprehensive, touching pretty much every aspect of the food system.
They absolutely are. They span environmental, social, and economic spheres. Beyond those huge environmental gains we just listed, better soil, less water use, lower emissions, Solera operations can directly lead to rural community revitalization. Profitable cattle operations support local economies. That's huge. It also represents a crucial recognition, finally, and honoring of indigenous knowledge and traditional breeding wisdom, bringing it right to the forefront of modern ag. And fundamentally, it enhances food security, providing climate-resilient protein production in what's becoming an increasingly unpredictable world. Economically, it offers premium market positioning for sustainably produced beef. Consumers are demanding that. It means significantly reduced input costs because the cattle are naturally adapted, less vet bills, less feed supplements sometimes, and ultimately enhanced profitability through better performance metrics, higher conception, lower mortality, better growth.
What's truly fascinating when you step back is that Solera breeders, they aren't just raising cattle, are they? They are, in a very real sense, stewarding a genetic heritage that spans 7 centuries and 3 continents.
That's exactly right. Each one of those animals represents this incredible convergence. Ancient Shona breeding protocols, Zulu military-pastoral excellence, the hard lessons learned from colonial research, cutting-edge modern genetic science. All aligned now with today's demands for sustainability. It's all in there.
This whole story of African cattle, it's ultimately a story of coevolution, isn't it? This powerful living partnership between human intelligence and animal adaptation, creating vital, living solutions to our biggest environmental and food security challenges.
It really makes you think, doesn't it, about how ancient genetics offer such potent modern solutions. The circle really feels complete. From those great stone cities of Zimbabwe, through all that history, to the modern pastures of Australia and beyond, the genetic excellence just continues to evolve and thrive, now purposefully guided towards a truly sustainable future.
So what does this all mean for you, listening to this deep dive? We've seen how centuries of adaptive breeding laid this incredible groundwork for today's powerful, sustainable solutions, like the Solera framework. And this raises, I think, an important question for you to consider. Where else? Where else might humanity find these kinds of truly living solutions to our complex modern challenges? Solutions found by looking back deeply at ancient wisdom and then adapting it thoughtfully with cutting-edge science.
It really challenges us, I think, to think differently about what true innovation actually is, recognizing that often the most profound progress comes from deeply understanding and maybe honoring what has already proven its resilience, its value, over vast stretches of time.
And keep exploring, keep questioning. And thanks for taking this deep dive with us.